students, good morning. I hope you all studied last class portion. What we studied in the last class? Extractive metallurgy of copper, right? There we studied their ores, then chemical properties, physical properties, some things we studied. Okay. Today we are going to learn uses of copper. Okay, uses of copper. Only 4 points are there. Here the first point is this copper is used in the manufacturing of electrical cable and other electronic appliances. Okay, so it is used in the electrical cable, manufacturing of electrical cable and other electronic appliances. That means electrical wires, cable wires. Okay, cable wires and other electronic, any other electronic devices. The next second point, copper is used in utensils, that means household articles. Okay, utensils, containers, calorimeters and coins. It is used in utensils, containers, calorimeters and coins. Utensils means household utensils, vessels, containers, that. Then calorimeters. Calorimeters means to measure the calories we are using meter. That is calorimeters. Calorimeter. Then coins. The third uses, it is used in electroplating. Electroplating means it is a process to coat one metal over another metal. Okay, coating process. That is electroplating. So in this electroplating also used copper. Okay. The last one, it is used in alloy of gold to make coins. Sorry, to make gold and silver. We are using this copper. Have you understood? Only 4 uses we studied. So first use, it is used in the manufacturing of electrical cable and other electric appliances. Second use, it is used in utensils, containers, calorimeters and coins. Then third use, it is used in electroplating. Electroplating means it is a process to coat one metal over another metal. The last, it is used in alloys. Alloys mean alloys. It is used in alloys. Alloys means copper with gold. That is a type of alloys. Okay, copper with silver. That is a type of alloys. So it is used in alloys. Have you understood the uses? Today we are going to study next topic, extractive metallurgy of iron. Extractive metallurgy of iron. In this lesson already we learned 2 more metals, right? What are the metals? Aluminium and copper. Today we are going to learn metallurgy of iron. You all know what is the symbol of iron? Fe. Okay, symbol of iron is Fe. This iron is the second most abundant metal next to aluminium. Aluminium is the first most abundant metal. This iron is the second most abundant metal. It occurs in the nature as sulfide, carbonate, oxide. So iron does not get in a pure form. It will combine with sulfur ore or carbonate ore or sulfide ore. So iron is the second most abundant metal next to aluminium. It occurs in the forms of sulfide, carbonate and oxide. We can see ores of iron. Here also, like aluminium and copper, here also 3 ores for this iron. First ore is hematite. Hematite. Then second ore is magnetite. Magnetite. Third ore is iron pyrite. Iron pyrite. What are the ores of iron? Hematite, magnetite and iron pyrite. So hematite formula Fe2O3. What is hematite formula? Fe2O3. Oxide ore combined here. Okay. Then magnetite formula Fe3O4. Okay. Magnetite formula Fe3O4. Then iron pyrite formula, it contains sulfide ore. So FeS2. Okay. Iron pyrite formula FeS2. So these are the 3 ores of iron. What are the ores of iron? Hematite, magnetite, iron pyrite. From these 3 ores, this hematite is the chief ore of iron. Okay, which is the chief ore of iron? This is important. One more question. Which one is the chief ore of iron? Hematite. Which is the chief ore of aluminium? Bauxite. Which is the chief ore of copper? Copper pyrite. So chief ore of iron is hematite. Okay, please remember it. And here next we are going to study extraction methods. Here only 3 methods we are going to learn, extractive methods. First one, concentration of ore by gravity separation method. Concentration of ore by gravity separation method. So gravity separation method, already you learned. Gravity separation method means we need to take crushed ore in a sloper table. Okay, crushed ore means powdered ore and washed with the steam. Steam means that it contains water. So crushed ore taken in a sloper table and washed with the steam. At the time during this process, lighter particles was washed away with water and this denser particles, that means denser ore is settled at the bottom of the table. That is a gravity separation method. Then second method, roasting. Roasting. So first method, concentration of gravity separation method. Second method is roasting. Roasting method already we learned in this copper. So here in this first method we will get one product that is concentrated ore. Okay, concentrated ore. This concentrated ore is roasted in excess of air. Concentrated ore is roasted in excess of air. During this roasting process, some volatile impurities. Volatile impurities means already I explained in the last class. Volatile impurities means easily liberated impurities. Okay, easily liberated substance. So when during this roasting process, volatile impurities and moisture will be removed. Have you understood this roasting process? So concentrated ore is roasted in excess of air. During this process, volatile impurities and moisture will be removed. Then third step, important step, smelting. Smelting process using blast furnace. This is important question, so listen carefully. Blast furnace. So this is the blast furnace. Okay, this is the blast furnace. In this blast furnace consists of 3 regions. Okay, this blast furnace consists of 3 regions, that is lower region, middle region and upper region. Okay, what are the regions here? Lower region, middle region and upper region. In this blast furnace we should take, first we need to take iron ore, coke and limestone. Okay, what are the things we need to take in this blast furnace? Iron ore, coke and limestone. So these 3 things we need to take in this blast furnace through this bell and hooper arrangement. Through this way we have to pour these 3 things. Okay, and this ores and coke and limestone consist their ratio 8:4:1. In this ratio we need to take these things in this blast furnace. So this blast furnace consists of 3 regions. What are the regions? Lower region, middle region and upper region. So listen, lower region. This lower region is otherwise called as combustion soon. Okay, lower region is otherwise called as combustion soon. Then middle region. Middle region is otherwise called as fusion soon. Middle region is otherwise called as fusion soon. Then upper region is otherwise called as reduction soon. Okay. So lower region is otherwise called as combustion soon, middle region is otherwise called as fusion soon, then upper region is otherwise called as reduction soon. In this lower region, here the temperature prevails at 1500 degrees Celsius. Here the temperature prevails at 1500 degrees Celsius. Here this coke powder, when it was heated, it will liberate carbon dioxide. So coke powder means that is a coal powder. Coal powder means that it contains lot of carbon compounds, right? So this carbon combined with the oxygen, when we are heating this carbon, the presence of oxygen, right? So carbon with oxygen, what temperature? 1500 degrees Celsius, it will form CO2, carbon dioxide, and heat. In this region, the heat is liberated. Okay, in this lower region, heat is liberated. So, it is called as exothermic reaction. This reaction is called as exothermic reaction. Have you understood this equation? Coke contains carbon, right? So, when we are heating this carbon in the presence of 1500 degrees Celsius, 1500 degrees Celsius with oxygen, we will get carbon dioxide and liberation of heat. So, it is an exothermic reaction. Then second one, middle region, that is fusion zone. So, in this middle region, what will happen presents? This carbon dioxide is reduced to carbon monoxide. Here the temperature is 1000 degrees Celsius. 1000 degrees Celsius. The temperature prevails at 1000 degrees Celsius. So see, CO2 here, when this carbon dioxide is reduced to the temperature 1000 degrees Celsius. 1000 degrees Celsius, then this carbon combined with more carbon, we will get, it will reduce to, this carbon dioxide is reduced to carbon monoxide. So listen, 2 carbon is there, so 2 carbon, then how many oxygen? 2 oxygen. So carbon monoxide, CO means that is carbon monoxide, CO2 means carbon dioxide. So this carbon dioxide, this middle region, carbon dioxide is reduced to carbon monoxide. Here heat is absorbing, okay, absorbing the heat. And one more reaction is there. Here limestone is there, no? So what is limestone formula? Calcium carbonate. So calcium carbonate formula CaCO3. Okay, calcium carbonate. CaCO3. When this limestone is decomposed to form, it will decompose, destroy to form, it will form calcium oxide, CaO. It can form CaO, calcium oxide plus this carbon, remaining how many oxygens are there? 2 oxygen. Okay, so CO2. This will also absorb the heat. This reaction also will absorb the heat. So this both reaction is called as endothermic reaction. Okay, liberation of heat means that is exothermic reaction. Absorbing heat means that is endothermic reaction. Here we got the product CaO and CO2, right? So when we are adding silica in this calcium oxide, the silica formula CSiO2. So when we are adding silica in this calcium oxide, it can form Ca, listen here, Ca, then this silica, then here 2 oxygen, here 1 oxygen, right? Totally 3 oxygen. Calcium silicate will be formed. So this calcium silicate is a based product slag, so we can remove it. Have you understood this reaction? So here calcium carbonate decompose to form calcium oxide and carbon dioxide, and this calcium oxide when added with silica, it will form calcium silicate. It is a slag. Okay. Then last one, upper region reduction zone. In this reduction zone, what will happen means, here also this carbon monoxide will reduce the iron oxide. Carbon monoxide will reduce the iron oxide to form iron metal. We can see the reactions, iron metal. So here we are taking iron ore. Okay, iron ore, hematite we studied now, Fe2O3. So when we are adding carbon monoxide in this Fe2O3, here the temperature prevails at 400 degrees Celsius. Okay, this lower region 1500 degrees Celsius, middle region 1000 degrees Celsius, upper region 400 degrees Celsius. So in this region, this carbon monoxide will reduce this iron oxide to form iron metal. Iron metal means Fe. Okay, here 2 Fe is there, so 2 Fe. Have you understood? Plus, here how many carbon? 1 carbon, and here 1 oxygen. Okay, here 3 oxygens are there, so it can form 3 carbon dioxide. It can form. We can balance this equation, 3 carbon and 3 oxygen. Then here 3 oxygen. So totally how many oxygen? 3 plus 3, 6 oxygen. So 3 2s are 6 oxygen and 3 carbon. Have you understood this reaction? So in this upper region, carbon monoxide will reduce iron to form iron metal and carbon dioxide. Have you understood this blast furnace melting process? So 3 regions we studied. Then next we are going to learn physical properties of iron. So in this last region we got iron metal, right? So thus formation of iron is called as pig iron. Okay, thus formation of iron is called as pig iron. Pig iron means that contains, pig iron means that contains 2.5 to 4% carbon, not pure iron metal. We got some carbon metal also. Okay, so this formation of this pig iron is remelted. Again it will be melted and cast into different molds. So that iron is called as cast iron. That iron is called as cast iron. Next we are going to learn physical properties of iron. So physical properties of iron, first point, it is the lustrous metal. Lustrous means it is a bright, okay, very brightness. So it is the lustrous metal and its color is greyish white in color. What is aluminium color? Aluminium color white, okay, greyish white. Then copper color reddish brown. This iron color is greyish, lustrous metal, greyish white. It has high tensile strength. It has high malleable and ductile. Malleable and ductile means made them to sheet or wire, anything. It can be magnetized. This iron has some magnetic character, right? So it can be magnetized. Next we are going to learn chemical properties. Chemical properties. So first point, first one, reaction with air or oxygen. When iron react with air or oxygen. So iron symbol Fe, oxygen symbol O2. Okay, air or oxygen. So here when iron react with the oxygen, when iron react with oxygen to form Fe3O4. Okay, iron oxide. Fe3O4. Now we have to balance this equation. So here 3 iron is there. So we can write here 3. Okay, here how many oxygen? 4 oxygen. So 2 we can add here. 2 2s are 4 oxygen. Have you understood first reaction? Then second one, reaction with moist air. Moist air, from this heading itself we can understand moist air means moisture plus air. Moisture means water. So H2O and oxygen. So when iron composed with moist air, oxygen and water. When iron composed with the moist air, it can form brown color ferric hydrated substance. It can form a brown color ferric hydrated substance. That formula is Fe2O3 XH2O. Fe2O3 XH2O. This is called as rust. Okay, so what is rust formula means Fe2O3 XH2O. Thus formation of rust is called as rusting. Have you understood now? So brown ferric hydrated. This name is brown ferric hydrated. Okay. So here now we have to balance this equation. 2 iron. So here also 2. Then how many oxygen? Here 2 oxygen. Here 1 oxygen. Totally 3 oxygen. It was balanced. Then XH2O. Okay. So Fe2O3. XH2O. This is reaction with moist air. Then next third reaction. Reaction with the steam. Reaction with the steam means iron react with water vapor. So iron formula Fe plus H2O. Okay, Fe plus H2O. It can form Fe3O4. Okay, Fe3O4. Iron oxide it will be formed. Here 3 iron. So here also 3. Then how many oxygen? 4 oxygen. But here only 1 oxygen is there, right? So we can here 4. Okay. Meaning how many hydrogens are there? 8 hydrogen. So that hydrogen will be liberated. Okay, it will be liberated. Then next one, reaction with chlorine. Reaction with chlorine. So in this reaction, iron react with chlorine to form FeCl. Okay, but here it can form ferric chloride. Okay, iron react with the chlorine to form ferric chloride. So Fe2Cl3. Okay, this is the formula of ferric chloride, or else we can write 2FeCl3. This is ferric chloride. Okay, here 2 iron, then how many? 6 chlorine is there, so we can write here 3. Have you understood this reaction? So reaction with the chlorine, iron react with the chlorine to form ferric chloride. Okay, the next one, reaction with acid. Reaction with acid. So what are the acids you know? Hydrochloric acid, sulfuric acid and nitric acid. So reaction with the acid, first one, iron react with hydrochloric acid. So look here, iron react with the hydrochloric acid, it can form FeCl2, okay, ferric chloride. So here 2 chlorines are there, so we can balance to this equation, so that we FeCl2, then remaining how many hydrogens are there? 2 hydrogens, so that hydrogen will be liberated. Okay, then next iron react with the sulfuric acid. What is sulfuric acid formula? H2SO4. Okay, sulfuric acid formula H2SO4. Now see, this iron react with the sulfuric acid to form iron sulfate, FeSO4. Okay, FeSO4 plus hydrogen is there, that hydrogen will be liberated. Okay, the next iron react with nitric acid. What is nitric acid formula? HNO3. Nitric acid formula HNO3. So it can form FeNO3. Okay, FeNO3 4. So here 4 iron FeNO3 twice plus ammonium nitrate. When iron react with the nitric acid to form iron nitrate, then ammonium nitrate and water. So ammonium nitrate formula NH4NO3. NH4 means, that means ammonia. Okay, ammonium nitrate plus water, it can be formed. 3 molecules of water. So here totally 10 hydrogens. So we have to balance this 4, then 4 plus 3 2s are 6, 4 plus 6, we got 10 hydrogen. So it is balanced. Have you understood three reactions? First one, iron react with hydrochloric acid, then sulfuric acid, then nitric acid. Then next we are going to learn uses of iron. Uses of iron. So uses of iron. Iron is classified into 3 types. Okay, iron is classified into 3 types. In the 2 mark question, maybe they will ask this question. Okay, so first type is pig iron. Okay, first one is pig iron. This pig iron contains 0.252 4% carbon. Not pure iron, it contains some amount of carbon. Okay, 0.252 4% carbon. This pig iron is used to making pipes, then stove, radiators, then railings. The railing means handrails. Okay, so it is used in making pipes, stoves, radiators, handrails, then manhole covers. Manhole covers means sewage cap. Okay, sewage cap and drain pipes. Drain pipe means sewage pipes. So this pig iron is used in making pipes, radiators, stoves, handrails, then manhole covers and drain pipes. Then second uses steel iron. Second iron, steel iron. It contains less than 0.25% carbon. Okay, it contains, the steel iron contains less than 0.25% carbon. It is used in construction of buildings, then machines, TV towers, transmission cables, something. Okay, so then third iron is wrought iron. Third iron is wrought iron. This wrought iron contains 2.5% carbon. Wrought iron contains 2.5% carbon. In this wrought iron is used in springs. You all know springs, right? ship, to stop the ship, they will use this anchors, iron rod. Okay, this rod. So that is made up of this rod tires, anchors. Okay, so first one, it is used in spring, is to make springs, then anchors and electromagnets. To make the magnet, they are using this rod irons. Have you understood? So uses of iron, three types of irons we studied: pig iron, steel iron and wrought iron. Okay. So all of you take your book. Take page number 117. Take page number 117. So here you mark it. Uses of copper. Write the uses of copper. Write the uses of copper. That 4 points. Mark it. Then metallurgy of iron, near that write down. Explain the metallurgy of iron. Explain the metallurgy of iron. Note it. Start from this first paragraph. Iron is the second most abundant metal. Then take next page. Up to this physical properties. Mark it. Physical properties. Then here smelting process. This is a book bag question also. The smelting process. Smelting, Roman letter 7, page number 123, Roman letter 7, third question. Explain smelting process. So you mark it. Answer page number 118. Smelting process. Start from this first paragraph up to this. This iron is called cast iron. This right side first paragraph. Upper region. Diagram on to draw. Okay. So whenever you are studying this equation, please write and study, then only you can easily understand. Then next question, types and page number 119, types and uses of iron is there, no? Near that you can write the uses of iron. Note it that 3 irons and uses. Pig iron, that paragraph fully, steel iron, that paragraph fully, wrought iron, paragraph fully. Okay, thank you, study.